Thank you, Sharon. Welcome, everyone, and thank you for joining us for this presentation. My name is Bob Glenn, and I'm one of the regional managers here at Teledyne ISCO. Before I hand it over to my friend and colleague, Jeff Vandehoef, I wanted to share a few things about our company. Teledyne ISCO is located in Lincoln, Nebraska, and was founded in 1958. We are a true manufacturer, not just an assembly house. So when we say we are made in America, we mean it. We specialize in the manufacture of rugged instruments used by professionals in the water, stormwater, and wastewater markets to protect water quality all over the planet, and have done so for 50 years, having invented the world's first automatic wastewater sampler in 1971. As we enter our second half century, we remain a world leader in the field of automated water sampling, and we remain as committed as ever to finding new and exciting ways to apply our products to safeguard the world's water. The recent use of our sampler products in wastewater-based epidemiology studies geared towards early detection of coronavirus is just one recent example of how our products continue to be applied to benefit mankind in our rapidly changing world. In today's webinar, we will briefly discuss different types of samplers and varying methods of sample collection, as well as providing you with valuable information on supporting accessories and other options to enhance the quality of your sampling operations. ISCO's Product Support and Service Group, or PSSG for short, is always here to assist our customers and is staffed with over a dozen professionals with nearly 300 years of combined experience in the environmental monitoring and water quality fields. With that said, I'll now hand things off to Jeff. Enjoy the presentation.
Hey, this is Jeff Vandehoef. I'm in the Product Support Services Group. I have been here at ISCO going on 32 years. Last about 6 years, I've been up in the Product Support Services Group, actually direct contact with customers, questions, any type of applications questions, any type of programming questions, just a whole bunch of different questions we get from customers. We're basically the front line, for that. What we're going to be going over today is basically sampler locations of your samplers, programming of the samplers, different bottle configurations that you can do your samplers, and then also different types of accessories that you can actually interface with your samplers to get the programming and the results that you actually want. So we'll get started here. So there are different types of samplers out there on the market. Three different main ones really are what there is. The main one, refrigerated samplers, are like more of a permanent type sampling system. They're also refrigerated, so basically it's just like a small little refrigerator. They are usually rugged, weatherproof type samplers. You can be outdoors, indoors. They usually require an AC power source to plug these in to run the refrigeration on them. Second type samplers that are out there are portable samplers. They usually don't have any type of refrigeration or anything like that. But they are smaller samplers that you can move and carry around. Actually, some of them are small enough that you can suspend in manholes to get sampling, from any type of manhole in your street or anything like that. The third one out there is like a portable refrigerated sampler. There actually has a little portable kind of 12-volt DC refrigerator that's on them, and it actually cools the sample, after the sample routine has been taken. So yeah, those are the three probably main types of samplers out there. View on how samplers work and what they do to actually collect your sample. Basically the basic principle how it works is there's like a strainer or something and a tube that goes actually down to the water. You have to start with a strainer. It brings water up through that strainer and actually to the pump. The pump brings it up, goes through the pump, and actually distributes into the different bottles. There are usually some type of contact or non-contact sensor here that actually says, oh, hey, I have liquid. Now I can start actually measuring my volume and putting the volume in the bottle. There's usually a keypad interface, there's the display, and there's also just like a microprocessor, mainly a little computer that controls your sampling, routine. When you actually take a sample, it does a pretty much a set routine, and this is what it does every single time it actually takes a sample. So the very first thing it does when the sampler starts running, the pump runs in reverse and actually blows bubbles down through your strainer and at the source. So if there's like sediment or anything that's built up here, it'll actually blow the sediment away and clear all of the water out of the line. So you get a true representation of, you know, the sample that's coming in or of the water that's actually flowing by at the time. The next part of the sample is it actually reverses the direction of the pump here. And it brings water up through the strainer, around, and then actually into the bottle. Deposits your set, you know, programmed amount that you have in there. After that, you know, pump stops, reverses direction, actually clears all the water out of the line again, and then sits and waits, you know, for the next sample. So basically it's a three-part thing every single time it takes a sample. Does a pre-purge, does the sample, and then does a post-purge. When you're considering a location for your sampler, there are a few things you really want to consider. Number one being a level pad. You want a nice level place to set the samplers. There's different bottle configurations for the samplers, and if you're doing like a smaller bottle or a 24 bottle system, if the sample's not level, then you can get some drift of the sample when you're actually trying to put it in the bottle, and it may miss the bottle and actually like put it in the middle of the base or something like that, and not actually in your bottle. Also, you always want it, yeah, someplace nice and flat and level. That way, you're not going to miss your bottles, and it'll take better samples that way. You don't also want it to roll off or, you know, blow away or anything like that too. Another thing to consider is the source. You want the source of the sampler to be lower than the actual sample itself. You don't want to have to try to you don't want to have to purge the sample uphill, basically, is what we say. So if the source was higher than the sampler, it will not let you purge out all of the water that's left in the suction line. It'll actually just blow air by the water. And then the next time you go to take a sample, well, you're not getting sample from the actual stream or the river or the source. You're actually getting the sample that was left in the tubing the whole time. So that's the main reason why we want the sampler head higher than the actual source, is so we can clear that line, you know, every single time it actually takes a sample. Suction line length is another thing to consider. We want to try to get the suction line length as close as we can, you know, get the sampler as close as we can to the actual source. If it's running a really long time to get the sample, that really eats your batteries, and it actually eats the tubing in the pump, and you can have a lot more wear and tear and stuff on the pump mechanism, you know, as well. So if we have it as close as to that, then you're going to get more samples per routine, and it's a lot easier to purge a shorter line like that as well too. So you'll definitely be able to clear the line a lot easier too, the shorter it is. The main two types of suction line, while we're talking about suction line, is vinyl and Teflon. Vinyl is probably the most common. You can find vinyl tubing pretty much anywhere, as long as it's like a 3/8 inch ID, you're usually okay with pretty much any type of vinyl tubing. Teflon tubing, a lot of people use that in case, you know, they don't want anything sticking to the inside. It helps, it's like a milky color. It also helps with, you know, algae growth and stuff like that inside the line too. But vinyl and Teflon are our two main type of suction lines that most people use. Next, we talk about strainers. It's important to get the right strainer that you're going to use for your application. So the strainer is the part that actually goes into the water. Low flow strainers that we have here are pretty much all stainless steel strainers. There are a smaller diameter strainer. So basically, if you don't have enough depth in your stream or your channel, you get this low flow strainer. It's about a 1/2 inch in diameter. That way you can actually pull sample, you know, from a lot smaller depths of water. If you're pulling air into the sample, well, then you don't get as much sample volume. You may not get all the volume that you need at the end if you're pulling air along with water. So we always want to make sure that that strainer can be submerged totally underwater. Most common strainer we see out there is like a poly weighted strainer, stainless steel ends on it to provide the weight. Actually, just throw that in there. There's usually enough weight in there to keep the strainer, anchored in place so it doesn't float or doesn't get washed downstream. Other strainers is like a CPV strainers here. That's basically an all plastic strainer. A lot of times when people are sampling for stuff or looking for stuff in discharge of plants or wastewater plants or even industries, they're looking for different types of metals and stuff like that. And if you have any metals on the strainer, well, then that can contaminate. So we just have all plastic strainers, basically to eliminate any metals in the sample. There's other different strainers out there too, but these are the most three common ones here. So another thing to consider is power options. Remote sites where you're setting up these samplers and stuff like that, you don't have access to the AC powers, so you can't use the refrigerated samplers, the permanent refrigerated samplers. So you have to use either the portable samplers or the portable refrigerated samplers. And, if it's way out in the country or something, and it's a really hard access to it, a lot of people will actually have a solar panel there as well. The solar panel actually maintains the battery while the sampler is sitting there, either waiting for a rain event or, a discharge event or something like that. When you're placing a solar panel, you definitely want to place it facing south most of the time. There's actual apps you can get online and look, and it'll actually tell you, your region. I think you enter your zip code, and it'll actually tell you what angle to put the panel and what direction to put it and everything like that. So definitely, we definitely want to face it towards the sun so you get the most charge of your battery, so it maintains your batteries a lot better. With samplers, most of the time, a solar panel is just going to maintain the battery. It's just going to keep it at a full charge. Once your sampling routine actually runs, there's quite a bit of current draw off of that battery. And most of the time, the solar panels, they'll keep a little bit of a charge on there, but they're not enough to keep up with the whole sampling routine. So you will, after the sampling routine is run, you will probably have to go out and replace batteries, when you collect your samples. But it definitely keeps the unit, keeps the battery topped off until you actually start your sampling routine. Talking about batteries, there are different types of batteries out there that you can use with the samplers. The two main ones that we have are either a lead acid or a NiCad. A lead acid is like your car battery, basically. It's a bigger, a little bit more high capacity battery like that. Has the same downside as like your car battery. In the wintertime, you get less cranking amps out of it, and the batteries just don't last as long. You don't get as much capacity out of it in the wintertime. When the wintertime is real cold, you try to start your car, it kind of turns over really slow. But you do get more capacity out of the lead acid batteries. The NiCad, the advantages to the NiCad are you get more charge and recharge cycles out of the NiCad batteries. So if you're constantly deploying a battery every day, you're deploying a battery and you're doing lots of charge recharge cycles, well, then a NiCad battery is probably what you want to go with on that. NiCad batteries are kind of what we see in a lot of the tools like drills and your tools and stuff like that around your house. That's what we mostly see NiCad batteries in. There's also bigger like a deep cycle marine battery, which is a lead acid battery, but it's like a big car battery that you can use. And a lot of times with like the portable glacier sampling and stuff, they'll use those big deep cycle marine batteries. They're like 100 amp hour battery. You can find those, locally anywhere. Very common battery, very common for people to use those on remote, like solar powered sites or just anywhere remote sites. Another thing to consider when if you're putting it out in, even in town or in out in a rural area or something like that, you definitely want to probably anchor the sampler down. This picture, I think, has it chained with a big log chain here to a tree there by a stream. In town, a lot of people will get like big storm boxes or enclosures to put them in, that where you can actually have a door on it and you can lock them up in there. I've seen people actually just pound fence posts in the ground and chain the units, to fence posts and stuff like that, just to secure it. Basically, if you're in an area that you think they may walk, or even float away, you definitely want to chain it down so you don't lose it. I've seen samplers like in manholes. I've seen them like surcharge. The manholes will surcharge, and if the sampler wasn't anchored properly, it washes that sampler totally downstream and everything like that. So yeah, you definitely want to anchor them so they'll stay in place. Talking about programming of the samplers, the main programming choices we see on these units are basically there's a time-paced sampling routine. So what that means is it's actually you pick the time interval. You say, I want to take a sample every 15 minutes, every hour, or everything like that. And so what it does is actually takes a sample every hour. So every hour here, we take a sample and it puts, so much 20, 30, whatever mils in the bottle every single hour. There's different types of time-paced sampling. Uniform time-paced, that's the one where it's, every hour, every 15 minutes. That's all user programmable for what you want. There's also option for non-uniform time. Let's say you want to sample all day long. So I want to sample, every hour, but I know over the lunch hour, we have a whole lot of discharge from our plant. So I really want to get more samples, during the lunch hour. So during the lunch hour, you can say, okay, I want to take samples every 15 minutes. So you're taking over that whole hour, you'll take 4 samples. And then once that's done, once it goes back, then you'll start taking them. It'll go back to every hour after that. And those are all user programmable. You can say, I want the first one at 5 o'clock, the next one at 6:30, the next one at 4. You actually have to enter all those times in there to tell you, when you want to take those samples. It's a nice feature to have in there if you don't want them, sample just every hour. Next one is flow-paced samples, and that can be a little bit more complicated than the time-paced. You actually will have like a flow metering device, a flow meter of some type that's actually interfaced with the sampler. It actually talks to each other. The flow meter actually measures the volume of the water actually that's going by. And then the flow meter will send a signal to the sampler that says, hey, I've had this much volume go by. I want you to trigger and I want you to take a sample. Basically, then it waits until, okay, the next signal from the sampler. And the flow meter keeps track of all that. And it says, oh, 500 gallons has gone by. Boom, take a sample for the thing. So the reasoning for that is if you're monitoring the flow, out of a plant to discharge or something, maybe they don't discharge all the time. Maybe at some points of the day, you're discharging a whole lot. If you did a time-paced sample here, well, you're going to take a sample here, you're going to take a sample here, and basically you don't have any flow at this time. So you want to try to concentrate all your samples when there actually is having flow. So this is kind of a representation of that. The blue line here is all our flow, and then this is the sample time. So we had flow, the points we have flow, that's where our samples are concentrated. There's different signals you can get out of different flow meters that you can send to the samplers. Most samplers are capable of either taking a 4 to 20 milliamp signal or a contact closure. So a 4 to 20 milliamp signal, what that is it's a flow signal. So at 4 milliamps, when the flow meter is outputting 4 milliamps, that means we have 0 flow. When the flow meter is outputting 20 milliamps, that means we have a full scale flow, and that full scale flow is set by the user. So anywhere in between, 12 milliamps is going to be about half scale flow. So the sampler can actually take that signal and monitor it, and it converts it to gallons, and it says, oh, I've had this many gallons go by, take a sample. Another thing is that a lot of flow meters have is a contact closure. Basically, it's a relay, and it closes, and it basically shorts 2 wires together. Every time it momentarily shorts those 2 wires together, that is what we call a flow pulse. and then the sampler will take a sample every time like that. You program up the flow meter to actually say, hey, well, I've had 500 gallons go by, close my contact, and then that in turn tells you to take a sample. Some samplers are actually a little bit more complicated. They actually can have like a flow module inserted into them, actually part of the sampler. So it's actually like a sampler and a flow meter in one. With those, you can actually say use its own volume that it's keeping track of and say, oh, 100 gallons has gone by, go ahead and take a sample. We call that pacing by flow module volume. So. Another thing, and not as popular, but it is definitely what a lot of people use for like remote sites and stuff like that, is what we call event paste. So event paste can be, you can use event paste from pretty much any, you can trigger it from any of the stored parameters that the sampler is keeping or measuring. There's different types of SONs and stuff, and we'll talk about that a little later, that you can actually hook up to the unit, and you can store, level, velocity, flow rate, even like dissolved oxygen, pH, temperature, all that kind of stuff. So basically, any parameter that we can store inside the sampler, you can actually trigger off of. So you can say, let's say, my pH rose to above 7. At that point, you can tell the sampler to start its sampling routine and actually start taking a sample. You can take one sample, or you can actually start the routine and start a flow pace routine after that. You can start the time pace routine after that, where it's just going to keep sampling and sampling until it's done, every 15 minutes. Or you can say, okay, basically that event happened, I can just take that one sample and be done. And then it waits for that event to happen again, and then it would take a sample, every single time that event happens. So a whole bunch of different options here on event based on how you can do that. I can start the program or just take samples, based on that. The next thing is bottle configurations. There are a whole bunch of different types of bottle configurations that you can have on these samplers. The most common one is probably a one bottle configuration, and we call that a composite, which is just a single bottle. The most common size is about a 2.5 gallon. That's probably, probably about 90 to 95% of the composite ones out there use a 2.5 gallon bottle. So it's a single bottle. It takes a series of samples over a period of time or a period of flow intervals, and basically collects it all, puts it all into one big, conglomerate, one big bottle. Bob talked about the COVID sampling earlier in his introduction, and most of the COVID sampling that we've seen people do, universities and stuff like that, where we've seen them do it, usually use a composite type setup for that. The next one is you have multiple bottle configuration. We call that sequential. So a bunch of different options there, anywhere from 2 bottles up to 24 bottles. Just depends on the model of the sampler and everything like that, as far as which bottles are available. So you definitely want to keep that. You definitely want to consider that when you're trying to select what sample you don't want to use. Some samplers are composite only. You can only have one bottle. So if you need sequential, then you probably need to go with a different model. Most common one we see is probably 24 bottles. It's usually 24 1,000 ml bottles. So how that works is it actually takes the first sample and puts it in the first bottle. You can either fill the bottle halfway, you can fill the bottle just a little bit. So you can take multiple samples and put it in one bottle. So like each bottle would be like its own composite little sample that's in there. Or you can just say, every time I take a sample, I just want it to put it in one bottle. Once that's done, then I want to move it on to the next one. At that point, so you can say, okay, that way when the sample was taken during the time of the day. So if you're doing a 24 bottle system in 24 hours, this one starts at midnight, and then this is going to be 1 o'clock, 2 o'clock, 3 o'clock, and so on. So basically, you found something in your 4 o'clock sample bottle, well, something was probably discharged right around 4 o'clock. basically it gives you a time interval of, of when that sample was discharged. Most samplers have some type of liquid detector that's on them. So the liquid detector works basically, it pulls, when the sampler pulls water up closer to the pump, it says, oh, I see liquid, I know we have liquid. At that point, it says, okay, I need to do this many pump revolutions to get, a 500 mil sample. One of the main things of the liquid detector is it actually gives you a more accurate sample volume based on that. It's because it knows right where the liquid is. It knows I'm right at the pump. At this point, I need to pump this many to get this much volume. Most COVID samplings, I think, use the liquid detector. That way you get a good, accurate volume every single time. Some applications, the liquid detector just won't work or it doesn't work right. So there is always the option to turn off that liquid detector. When you turn off the liquid detector, then it would just base the sampling routine on the number of pump counts. Basically, it says, okay, I have a 25-foot suction line and I want to get 500 mils. It knows it has to pump, forward so long to get the 500 mils, according to the suction line length. Reasons you would turn off the liquid detector, the most common are is if possibly, like if you don't have a lot of depth in your stream, and the sampler strainer is not totally submerged. Sometimes you can get air in the line with the actual water. And at that point, that can cause problems for, the liquid detector, because it's seeing liquid, then it's not seeing, then it sees it. So it really is hard to calculate, the volumes that you need for that. If you have a lot of entrained air in there, that can cause problems and stuff like that. If you, like I mentioned before, if you have an application where the source is higher than the actual sampler itself, well, then it's seeing liquid all the time. And then, it can cause problems with the liquid detector on that kind of stuff too. So it's always a nice feature in there that, you can turn off that liquid detector, get a little bit more accurate samples if you have, problem applications. So accessories. Lots of different accessories you can actually hook up to the samplers to trigger the samplers, to tell it when to take a sample. Basically monitors different types of chemicals or whatever in the stream to basically say, oh, now I want to start my sampling routine. One of the most common ones we see, and one of the most basic ones, is a liquid level actuator, is what we call it. Basically, it's a contact sensor that actually goes from the sampler, and then it's a cable that actually goes down in like the stream bed or something like that. Once water actually makes contact with that sensor down in the stream bed, that sends a signal up to the sampler and tells it, oh, hey, you can start your sampling routine. We know we have water, present there. Another one is different types of sondes you can actually hook up to the unit. So the sondes actually measure different types of parameters in there. They actually measure like pH or dissolved oxygen or turbidity, temperature. Even I've seen ones with like a pressure sensor that can actually measure the depth, in the flow. From that, they basically, most of the sondes, or a lot of sondes out there, will actually speak SDI 12. It's it's like a communication language, between the sonde and the samplers. Some samplers are capable of interfacing with that, so they can basically take all the readings from that sonde, store it in there, and they can use all of those to trigger, off of. My pH goes above a certain value, then start the sampling, take a sample at that point. Another common accessory people use is a rain gauge. For stormwater sampling and stuff like that, we get a rainstorm. You've had, over an inch of rain in an hour. At that point, sends a signal to the sampler and says, hey, start my program. I want to start collecting samples right now because I know I've had a rain event. Rain gauges and the liquid level actuator are probably the most common that people use on those. So other accessories is flow meters. There's different types of flow meters out there. Pretty much all of them are capable of interfacing, with pretty much any sampler. Lots of different flow meters out there. These are our area velocity type flow meters, laser flow meters here. yeah, pretty much lots of different samplers or flow meters out there that will interface with samplers. So another thing to consider, if it's going to be a remote location or something like that, we have modems that you can actually hook up to the samplers. The modems help you interface with the samplers. They can actually tell you when the sampling routine has started, tell you when the sampling routine is done. They actually send out text messages to you, tell you what's happening with the unit. You can actually even contact the unit and pull the data off of the unit, remotely, so you don't actually have to go out and make a site visit to see it. They'll send out text messages when the program started. You can even say you can send it a text message that will actually start the program up and everything like that. So yeah, modems are very common, seem to be nowadays. It's basically like a cellular modem, just like your cell phone. It goes out and you have to have a cell plan with it and everything, and then you go out and you can communicate it remotely with it. Pretty nice accessory to have. So that pretty much is it on the presentations. At this point, I think we'll go to questions if you have any questions.
Thank you, Jeff. And as a reminder to our attendees, if you can submit your questions through the Q&A function in Zoom, this is very beneficial to us because it allows us to capture the questions just in case we run out of time to answer. We have received a few questions via chat, and I have captured those questions, and we will get to those shortly. Jeff, the first question is, you mentioned metal strainers influencing detection of metals. We perform stormwater sampling in some streams and test for copper, lead, and zinc. Should a plastic strainer be used instead?
Yeah, can you hear me, Sharon?
I can.
Okay, good. So yes, anytime you're sampling for metals, you don't want like a strainer that has metal on it, cross-contaminating your samples. If if it's a stainless steel and it doesn't have any of those chemicals on it, then we wouldn't have to have a plastic strainer. But just to be safe, yes, I would probably have a plastic strainer on that, so you don't contaminate your sample with other metals. So.
Thank you. Our next question is, if the liquid level actuator stops seeing water, does the sampler program stop?
Yes and no on that question. So the liquid level actuator is the device that actually goes down into the water, into flow. When water actually makes contact with the sensor, and that could start your program. So there's two different modes to the liquid level actuator. There's a latch and there's a toggle mode. If you have it in the toggle mode, then whenever there's water presence, whenever there's water touching that sensor, then yes, the program's going to run. As soon as that water goes away and it's not touching that sensor, then that will disable the program and cause it to stop running like that. So yes, it'll toggle back and forth between running and not running the program, depending on if water is touching that sensor or not. The other mode operation for those is a latch mode. So that is basically when water hits that for one time, the first time, then it latches that program on and it just runs that program the whole time. No matter if there's water there or not, it will continue running that sample. And that's called a latch mode. And there's just a switch on the unit that you can go back and forth between toggle and latch. So.
Okay, thank you. Bob, we have another question from Rachel. Can you comment on ideal length of overall suction line length? The manual says it can be up to 99 feet.
Yeah, so most of our samplers, you can actually go up to 99 feet on there. That's the programmed limit that you can do on there. So you can do that. The unit is capable of doing that, but really you're going to do a lot of wear and tear on your pump and a lot of wear and tear on the actual tubing that's in there. Optimal length that we want is probably, 25 feet or under is going to be the, the optimal length. I mean, can you go 30, 40 feet? Yes. But you want to try to get it as close as you can. It's going to save on battery life, wear and tear on your tubing and everything like that. Also, it will get a quicker sample for you, and you can take more samples in a shorter amount of time. So yeah, we always say try to get it as close as you can to it, but I mean, if you can't and you can only go a certain part, then yes, you can have it closer. There are other options of samplers that I didn't really talk about in the presentation. It's called a vacuum sampler. Vacuum samplers doesn't have a mechanical mechanism that actually has tubing and stuff in it. There's no mechanical parts on it. It's just like a vacuum pump. And there's a solenoid that changes, between vacuum and pressure in the line. So with one of the main advantages of the vacuum samplers is you can actually go on some of them, you can actually go up to 300 feet on your suction line. And then you don't have the wear and tear on your tubing and stuff like that. So if you have to go 99 feet and there's no way around that, I would probably recommend doing some type of vacuum sampler for that. They would be better with that longer suction line length. So.
Hey, Sharon and Jeff, this is Bob, and I just want to chime in on this last question as well, related to the suction line length issue. It's always, yeah, I mean, you're right, we can go a pretty significant distance with that suction line. But one thing that we try to do as much as we can is to get the suction line in a vertical orientation, if at all possible. And that is, especially when you start getting into long distances where you have 50, 60, 70 feet of suction line. Oftentimes that's not purely a vertical lift. And so you'll have some diagonal or horizontal stretches where water can potentially pool in that suction line. The purge mechanism, which is both pre and post part of the sample cycle, will get rid of most of that water. But if to have the suction line in a vertical orientation, you have gravity helping you to purge as well. And while it's not a deal breaker to have a little bit of water left in the line in between samples, you certainly don't want to have that if you're located, let's say, in northern Wisconsin, and it's an outdoor application at a plant and it's in the middle of January. So standing water in a suction line could easily freeze in between samples and cause some operational problems as well. So one other factor with your suction line is try to keep it in as vertical an orientation as possible whenever you can.
Yeah, you want a natural slope pretty much all the way down to your source. That way it clears it out on there. If you want to go with the peristaltics, with the pump ones, there are other programming options that we can do in some of our samplers that will lessen the purge counts. So we have ways of getting around, excessive wear on the pump and stuff like that, where we can lessen the purge counts, do a defined sample and stuff like that. So if you have to you can talk with us and we can help you with those, programming choices to a little bit less wear and tear and a little less maintenance for you. So.
Thank you, gentlemen. Our next question is, for the modems to work properly and to be able to operate them remotely, I'm assuming they need to be positioned in an area with cell service. Is this correct?
Yes, we have to have an area that has cell phones. It's basically the modems we offer. We have either Verizon or AT&T and T-Mobile. But it's pretty much the same as your cell phone service on there like that. So if you go to an area and you don't have any cell phone service there, just your normal cell phone, then yeah, the modem's probably not going to be a good option for that site because it may not actually get that type of service there. So yes, they are actually service plans with Verizon, AT&T, that kind of stuff. So yeah, make sure you do have good cell service in there. So.
Okay, our next question is, I have a 6700 series auto sampler here on site that has not been used in years, and no one seems to know the basic equipment necessities to get the sampler started. Can you go over the minimum equipment requirements to do this, such as suction line strainer, batteries, and if there's anything else?
Yeah, that pretty much covers it right there. You need the suction line. That's the harder tubing that goes down to your source, down to your water. The strainer is, strains out the big particles or any rags or anything like that that's in the water. And then some type of power source, a battery. If you have AC power available there, we actually have AC converters that will convert from AC to DC to run those samplers. But those are the three main things on there. I assume if nobody's touched it for a while, you probably don't know how to program it and everything like that. We have a tech support line here. You can give us a call, and we can step you through the programmings of the samplers and everything like that. And we can answer any other questions that you have about that. But yeah, those are the main things: the power source, your suction line, and a strainer. I would assume you probably still have the bottles and everything like that too, but that would be another thing to consider is, make sure you have a bottle. So.
Hey, Jeff, I'd throw in, your pump tubing. If the unit's been sitting for several years, you probably should inspect that pump tubing. Sometimes silicone-based tubing can dry out or get a little bit more brittle over a period of time. So pump tubing would also be another factor.
Definitely, yes. Pump tubing. Yep.
Okay, our next question is, what is the recommended purge interval for a signature bubbler meter? We have noticed our signature meter dies after about 2 weeks from a 12-volt marine battery, and wondering if this is the cause or that is normal.
So yeah, the signatures is one of our flow meters. That's not really with the samplers here, but you can put that purge interval out. I think it's 15 minutes by default. You can put it out to like 2 hours or something like that. It does have an effect on the battery life on those and stuff like that. But yeah, there's other things like when you're reading the different sensors and stuff like that can cause more current draw on that. For that question, I would probably want to give our tech support line guys a call. They'll be able to help you, more with that current draw. I'll just mention that number quick here. That number is 866-298-6174. And we have people there from 7 a.m. to 5 o'clock Central Time, Monday through Friday. Again, that's 866-298-6174.
Thank you for providing that phone number, Jeff. We have another question. How does a sampler adjust the sample volume when calibrating the unit? If I input a volume after calibrating, it seems to always overcorrect.
Okay, so when you calibrate the volume, so let's say you took a sample and you got 50 mils, and but what was actually delivered was 20 mils. You actually have to tell it, no, I only got 20 mils. At that point, it increases the pump revolutions forward, how much more it needs to actually, take a sample. It says, oh, I need 20 more mils. I need to pump this many more revolutions, to get that sample volume. If it's always over calibrating and never going right, there's a whole bunch of different stuff that can be causing issues there. Like I said in the presentation, air in the line. If we have a leak in one of the connections from the sampler to the suction line, that will cause issues. If you're getting a lot of entrained air in the unit, that will cause problems with the liquid detector. There's mechanical things with the liquid detector too, like there's like a cover that goes over that presses the tubing up against the liquid detect sensor. If those covers aren't tight, that'll cause problems. Even putting your pump tube in backwards will cause intermittent volumes and liquid detect errors and stuff like that. Most of the time, if you're getting liquid detect problems or volume problems, it's usually something on site that's causing the issue. Liquid detect sensors are very good. I say this all the time. I've been here over 30 years and I've maybe replaced 5 liquid detectors in 30 years. They just don't go bad. It's usually a site related issue. And like I said before, we have the option of turning off that liquid detector, and you can still do a calibration with the liquid detector off, and it does the same thing. It just bases it on your suction line length. It'll increase that and decrease that until you get, the volume that you want. If you still can't ever get it to work, again, give us that call at that number, and we can help you work through everything and get that, working for you. So.
Thank you. And see, we have another question here. What would you recommend to keep your sample at the minimum required temperature for a sequential sampler?
Well, we really don't have too many temperature requirements. The low temperature is above 32 degrees. Basically, because your sample is going to freeze at that point, and it'll freeze in the suction line. You actually won't get a sample. We do have like 120 degrees as the max for like the actual controller temperature and stuff like that. It'll start interfering with the display and stuff if it gets hotter than that. The temperature that we can pump with our tubing is actually up to about boiling before it will start affecting the actual suction line and the actual silicone tube in there. So we can go quite hot for the liquid that you're actually sampling in there too. But yeah, pretty much from freezing, in between freezing and boiling for the sample water temperature, and maybe up to about 120 for the actual air temperature. So, but really most time we don't ever run into that issue. So pretty much as long as you're above freezing, you're usually okay. So.
Yeah, hey Jeff, I'll throw in an answer on this too. I think maybe what they were driving at there a little bit is, an optimum temperature to target for preservation of the sample. And of course, EPA recommends a guideline of preserve it at 4 degrees C or less. In between 4 degrees and 0, of course, would be freezing. And for a sequential sampler, you have multiple bottles in there. It really there's a lot of variables that you have to consider. The nature of the source water, as Jeff stated. If it's just regular storm water, temperature wise, it's not going to be real warm, and the amount of cooling ice that you need or what have you would probably be not as great as if you were sampling an industrial source, let's say, that is discharging, from some clarifier from processed water that's quite a bit warmer. So it's kind of a hit and miss thing. We do have the ability to store temperature as a data set. With some of our samplers. So, if you wanted to monitor that temperature and pH at the time of sample collection for each one of those individual bottles, you could do that with our model 6712. And that would give you a written record document the sample temperature at the time of collection. And we also could potentially even have the ability to log the temperature inside of the sampler enclosure using the 6712 as well. So there's a lot of flexibility there, and a lot of it is really hit and miss based upon the type of water that you're sampling, the process that you're sampling, the part of the country that you're in at the time, et cetera, et cetera, et cetera. So a lot of variables, and as Jeff said, use that number and give us a call if you have questions, because there are literally thousands of variants involved in all of this, and it's impossible for us to cover every one of those in a webinar like this.
Thank you, gentlemen. We received another question through the chat function, and it is, can you trigger off of turbidity?
Yes. Yeah. So basically any parameter that we're measuring and storing with the sampler from like a sonde or anything or other interface device, as long as we are recording that as a data parameter, we can trigger off of that. So yes, we can trigger off of turbidity, pH, anything the sondes are reading, we can trigger off of that, no problem.